This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. Alright, you should have already watched the video on what a reference angle is and how to find it. And so before we go over how to use reference angle, let's just do this problem. Alright, it says sketch 7 pi over 4 and state its reference angle in degrees and radians. Alright, so to sketch 7 pi over 4, some people could do that in radians. And I think of it as this is 1, 2, 3, 4, 5, 6, 7 pi over 4. It's going to be over here. And so this is how to sketch the angle 7 pi over 4. Now if you can't go directly there, then go ahead and you could change 7 pi over 4 to degrees first. So remember, pi is the same as 180 degrees. You can just replace pi with 180 degrees. That's one method of many to convert it. And so if we cancel here, we're going to get 45 degrees there. So I have 7 times 45 degrees, and that's 315 degrees. So someone else may have sketched this by first changing 7 pi over 4 to 315 degrees and then realizing it's over here. All right, so that we've done step 1. We have sketched 7 pi over 4. Now it's asking us to state its reference angle in degrees and radians. So now we need to know what this angle is here. It's an angle between 0 and 90 degrees. And if you want to do it in terms of degrees first, you could say, well, all the way to here is 360. You're going to subtract the 315. So 360 minus 315 is 45 degrees. So reference angle in degrees is 45 degrees. In other words, this is 45 degrees. And if you change that to radians, that's pi over 4. And some people could see, well, if this is 7 pi over 4, one more pi over 4 gets you to this back to 0 or to 360. So that's an example of sketching an angle and then stating its reference angle. So I was given an angle in radians this time. You might be given an angle in degrees. So here's an example where we're given an angle in degrees and asked to state its reference angle in degrees and radians. So let's try this one. It says sketch negative 240. All right, this means I have to go in the clockwise direction, negative 240. So let's see. From here to here is 180, and then I got to go 60 more, right? So that is the angle, negative 240 degrees. So I've sketched the angle, and then I want to know what the reference angle is. So the reference angle is this angle here. Remember, it's the angle that the terminal side makes with the x-axis. All right, so how could you figure that out? Well, it's 180 degrees here, and 240 here. You could just subtract those numbers to figure out. In other words, you could think of this as negative 280 and negative 240, but it's basically going to be the same. What's this difference right here? And that would be 60 degrees. So the reference angle, 60 degrees. And if you change that to radians, that would be pi over 3 degrees. If you have trouble going back between degrees and radians, make sure you see my videos on converting back and forth. All right, so now why do people use reference angles? All right, to calculate the trig function of an angle, you can determine the quadrant of the angle to find the sign, in other words, positive or negative, for that function. And then you attach that sign, positive or negative, to the trig function of the reference angle. So here's an example. Find the sine of 150 degrees and the tangent of 150 degrees. So first step is just figure out the reference angle. So let's see. If I do that, I know that it's over here, 150 degrees. And then I'd have to figure out the reference angle right here is 30 degrees. All right, so the reference angle is 30 degrees. So what I'm going to do is determine whether the sine of 150 is positive or negative and the tangent is positive or negative based on the quadrant it's in. All right, so we're over here in the second quadrant. Is the sine positive or negative? Now, I always think of what the y value is, but you could also do all students take calculus, and notice it's the sine that is positive in the second quadrant. So we know this is going to be positive. All right. The tangent will be negative because the tangent's only positive down here in the third quadrant or in the first, like all of them are. So the tangent will be negative. I think I'm going to need a little space here, so how about I put that down here? That's going to be negative. Okay. Once we do that, once we determine the sine, we could just take the sine of the reference angle. Okay, so you determine the SIGN, positive or negative, for the actual angle, 150 degrees. And then you could just use the reference angle to get the answer. And a lot of people like doing this because they just look at the little special triangle, 30 degrees, or they've memorized it. I never memorize it. I always draw it every single time. So let's see, that's 30 degrees. And I know that's the smallest side's 1, hypotenuse is 2, that's square root of 3. So the sine opposite over hypotenuse is 1/2. So this is positive, right, 1/2. So that's the sine of 50. The tangent will be negative because of this negative sign. And now what will the tangent be? It'll be 1 over the square root of 3, right? It's opposite over adjacent. 1 over square root of 3. Let me write that better. Negative 1 over square root of 3. Now, that's not rationalized. So, of course, if you were going to rationalize the denominator, it would be written like this. That's the simplified way of writing that. Okay, so that's how you could use a reference angle. I don't do this. I actually, once I've got my, if I have to think it's over here anyway, I just draw a triangle there. So let me show you how I do this same problem. So here we are again. Find the sine of 150 degrees and the tangent of 150 degrees. I'm actually using the reference angle, but I don't write all that out. I think, well, 150 is over here. Right? That's 150 degrees. So I just drop a perpendicular. It's always to the x-axis. And I can see this is just a 30-degree angle. And then I just fill in the sides. This has to be 1. That is 2. And that's negative square root of 3. I'm thinking of like the coordinates of the x and y values here. And then I know for the sine of 150 degrees, it's going to be the y value over the hypotenuse, over the r, 1/2. And for the tangent, it's going to be the opposite over the adjacent here, or the y over the x. You could think of it as a triangle, or you could think of it as the values on the x-axis, but be careful that minus sign there. So I would have negative 1 over square root of 3. Same answer as I did it using reference angles. To me, it's just easier once I've drawn the, this angle anyway, to just go ahead and fill in these lengths of the sides. So look at the difference. Whoops. The way one would use reference angles, they go ahead and draw the picture, state what the reference angle is, but then just look at this little triangle. All right, and pay attention to whether the answer is going to have a plus or a minus in front of it. All right, so they're equivalent to each other. It's up to you which way you do it. We'll do some more examples on the next video. This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.